It was mentioned that not all locations might be suitable for PRPs. Can you describe some examples?
Sure, not all locations will be suitable, but we've done a lot of work now on finding really suitable locations. So we started in the offshore zone using specialized core water evaluation equipment to find areas that have high nitrogen loading, using some specialized equipment that Ron can talk to you more about if you're interested. But we find these high nitrogen loading zones that are directly contributing nitrogen into the surface water and then moving inland. We can then characterize the soils, the groundwater velocity, and other parameters that will help inform the design of a PRD. And in general, these areas are going to be high groundwater discharge areas, high nitrogen loading, so we can start to look at land use, and we do use the Suffolk County Water Wastewater Plan to kind of use that first to look at where areas will be ideal, and then we can go in with taking direct measurements to really inform the site that would be ideal. But high nitrogen loading, fast groundwater discharge, permeable sediments, and bulkheads have been a great starting location because PRDs can provide an added environmental benefit that bulkheads provide no environmental benefit as is. But even in areas where there are wetlands that are able to remove some nitrogen, but not all the nitrogen, and PRDs can be installed upgrading of wetlands to make sure that they're not being degraded and to help protect those wetlands. So that's kind of the short answer as to where they would be best installed.
With regards to the sugar kelp production, breaks out two locations that I saw were right by the units. Is there limitations in terms of salinity and turbidity for cultivation? And again, it's probably the areas that need the most help. I'm talking about more towards Patrick Bay, Gulfport Bay. Are those areas a possibility, or would the inlet closer to?
So there is a salinity, ideal salinity. So being close to the inlets definitely makes it a good spot. I think in general you want salinities above 25. Although there's been projects where it can grow lower, but you get the best growth above that. And there's also light requirements. So yeah, there are situations I think where if the water was too turbid, that would decrease growth. I'm going to pass the mic to Charlie because he's going to say something a lot smarter than me.
Well, I just wanted to mention that turbidity is not going to be a problem in the sites that you talked about. If you look at the East River, the turbidity is basically lights out 2 feet below the surface. And the idea is establishing the farm near the surface water. And you can do that in the sites that you mentioned right there. It's not a problem. Kelp saturate photosynthesis very quickly and at low light levels. And they just purr along as increase in light is available.
Another question from the chat. When growing kelp, does the fact that it shadows the bottom affect the marine life on the bottom?
One thing, I'll pass it because Mike is my expert for shallow water. Mike mentioned 18 foot was a number that was used for the depth of floating systems. The way I came up with that 18-foot number was below 18 feet, you're not going to have any SAVs. And one thing we didn't want to do early on in kelp cultivation was negatively interact submerged aquatic vegetation. We're very sensitive to that. But in shallow water, where you don't have SAVs, but you have a big problem, Mike.
There's not much growing during the winter in terms of SAVs, so I don't think that that there's going to be too much of an impact of anything growing on the bottom. Also the kelp moves with the tides, so it's not constantly shading the same spot, so it will drift, flow one way with the incoming tide, flow the other way with the outgoing tide. But one of the reasons it grows really well in shallow water and very clean also, and that was one of the the concerns was that, being so close to the bottom, it would get grazed and fouled really easy. There's not much, everything's sleeping in the winter, so there's really not much there, not much biological activity that's really found on the kelp, and there's not much, biological activity that the kelp is interfering with during that time.
Okay, well, with that, I'm gonna wrap up this session. You've all